Good evening, everyone, and thank you for joining the DevOps Live meetup. My name is Mike Rosato, and tonight we have with us Himanshu Patel. And Himanshu is from a company called
Eventive.
Avantiv, right? Hold on a second. There we go. Sorry about that. A little bit of feedback. So, yeah, and he's with Avantiv, right? Technologies, and he's the head of middleware technologies. And but before we go with Imanshu on his presentation tonight on evolving DevOps in the age of Kubernetes, I want to let everyone, as a reminder, know that on April 17th, I tweeted about this. April 17th is the spring break edition of All Day DevOps. So please go out and register for that. It's going to be a lot of talks on that uh, All Day DevOps, and it's kind of like a preview of what's going to happen in November, where they have a full 24 hours of All Day DevOps. And also, I know that a lot of us have been dealing with having to stay and work from home, and because of the COVID-19 virus. But we still are on gear to have the DevOps Days Dallas DFW on August 26th and 27th. So if you haven't bought your tickets, I think we're probably going to extend the early bird registration for All Day DevOps. If anything changes, we will sure let everyone know if we have to postpone the date. I don't see that happening, but you never know. Things kind of creep up on you in the last minute. So without further ado, I'm gonna go ahead and let Himanshu kind of explain a little bit about himself, what he's been doing, and then get started with the presentation. Also, I want, if anybody has any questions, please post them on the right. If you're watching it on YouTube, on the right hand side, there's a place for comments. And when you post your questions in there, we'll pop them up right here. They'll appear on the screen at the bottom, and then we could ask Himanshu about whatever is burning in your minds. Okay. Well, so without further ado, I'm going to go ahead and pass it off to Himanshu.
Thank you, Mike. Really appreciate that. Thank you so much for hosting this event. Uh, I'm glad that technologies such as me can connect and network. This is a great opportunity. Thank you so much. Thank you so much, everyone, for joining with me this evening. As Mike said, I'm Himanshu Patel, and I'm technologist and DevOps enthusiast like many of you. Currently, I lead middleware technologies at Eventive here in Dallas. And in the past, I have also worked at Bank of America, Chase, and ThoughtWorks. Uh, before anything else, I would jump right into the session. This session isn't a sales pitch, so I won't impose any specific product or services here. So sit back and relax. This session rather is more philosophical around DevOps space that I have seen evolving in the last decade or so. I'm sure you guys have witnessed that as well. The journey of DevOps in particular is quite fascinating to me, that I would like to explore with all of you tonight. As we all know, DevOps is a culture, and thus its adoption isn't that easy. Cultural transformation and driving mass behavior is a continuous problem across industries, and unfortunately, DevOps is no exception. Well, this might be familiar to some of you. It's a theory of golden circle from Simon Sinek. I personally like this concept. Simon talks about starting with why, to influence people and driving mass behavior, which is essential for cultural transformation. And the examples he gives are the companies such as Apple and legends such as Dr. Martin Luther King Jr. and Wright brothers. We all know that they managed to move mountains despite of tons of challenges they faced. So great leaders start with why, as it impacts directly to the human mind. And then they actually move down, to how and what. So little extra detail here. The human brain comprises of limbic system as well as a neocortex. While the neocortex handles logical and abstract thinking, it's the limbic system that actually controls human emotions and thus holds the overall decision making. And it's been revealed through a series of experiments that why activates limbic system. And it basically engages limbic system and influences and creates very deep impact and influence on your mind. So although there have been reasons and matrices around DevOps, it would not be widely accepted across the mass until the DevOps evangelists convey why DevOps. So it's very important to basically start with why DevOps. So I really would like to start this journey today with that exact same thing. Also, that thing isn't really, not new. It's been pretty ancient. You can see here the Buddha meditating very peacefully and in a calm state. One of the famous sayings from Buddha is, "The mind is everything. What you think, you become." And that proves the point that if something strikes the mind of people, it becomes easier to get their buy-ins. So let's start our journey with why. Why DevOps? For exploring the journey of DevOps and why it really came into existence, I have divided the technology evolution into 3 timeline phases: early evolution, hypergrowth time, and high risk time. Don't quote me for 2007 here, but many statistics and surveys shows that after 2007, the IT industry changed dramatically. So we'll talk about the time until 2007 to start with. So in the early evolution period, this picture was sort of like, more a reality, more common, right? It's pretty funny cartoon. It has been used in a variety of contexts. Some of you might have already seen it. I find it quite relevant for our DevOps topic tonight. So that was a time when we rode the wagon with square wheels. There were some early adapters and geniuses who tried to help with rounded wheels, but we said, no thanks, we're too busy, right? That sounds familiar, I guess. So, well, that was the time when we hardly knew about infrastructure as a code, platform as a code, security as a code, CI/CD, automation. None of that really mattered too much. Also, on the same note, this particular was also the scenario. Every single group operated in its own silo. They all worked in their own little world with, much lesser integrity or collaboration with the others. As a result, the culture of throwing it off the wall was created, which means the one group threw it off to the next group, over the wall without worrying about whether they are going to sink or swim. As you can see, between these silos existed the wall of conflict. And this wall of conflicts created a lot of problems. And those problems are the ones that we're going to see next. Still, the approach really worked in early evolution time, but at times we also saw things like this: the development throwing the releases off the wall to ops, and boom. That also sounds pretty familiar. At least it was the case, in early evolution phase. The old way had the silos of roles built around the organization, and that basically created a lot of anxiety, uncertainty, and the process of software delivery was pretty much manual, fragile, and broken. It lacked repeatability and predictability. Well, that reminds me of one of my old projects. It was a huge monster, had about 90 modules interdependent. Can you believe that? 90 modules interdependent. And on top, there was no build tool. It was a manual, multi-stage, highly complex and fragile building process. And to make the matter worse, the nightmare was the whole mammoth project could be built on only one single specific server. You could not really build it locally or any other environment. There was no CI/CD server. All you have to do is just kick a bunch of shell scripts to basically use Ant to build all of those. And that magic one server where it was built had all the local dependencies that all those 9 modules actually needed, right? The cost and risk of the change was too high, and we literally avoided making changes for a long time. So that was the day, and that was the time. As you can see in this picture, it's an old government office monitoring resources. You can see everything pretty calm and under control back then. Well, except one day, they hit Y2K challenge and things fall apart. And just like this picture, things still worked for us in evolution time, and we lived with it without any problems until the culture of throwing off the wall and manual processes started. And that happened when we actually entered into the next phase, and that was the hypergrowth time. So as you can see here, in this hypergrowth time, so many technology innovations came through, and many new breeds of gadgets were thrown into market for personal and professional use. More and more industries also started adapting technology and conducting their businesses online. Well, Apple also released their first ever iPhone in 2007, and so did Amazon launched its basic cloud platform AWS around the same time. And sadly or gladly, this hyper innovation time heavily changed how we live our day-to-day lives. Also, on the other hand, which is on the brighter side, it generated tremendous demand on technology and for technologists all across the globe. You can see in this graph, the global data sphere is climbing up over the last decade due to the technology became quite inevitable. More and more systems, more and more organizations, moving towards the electronic data, and that basically, boosted up the footprint of global data sphere. The other graph shows no different than the earlier one. It shows pretty much the same thing, that the global data sphere growing across the regions across the globe through last decade or so. Also, during this time, the concept of cloud emerged to manage the complexity and cost of the computing and storage needs for personal and commercial usage. As more and more businesses and individuals started becoming, technology centered, it was essential to basically bring the cost down and increase the flexibility. So graph here actually shows that the amount of data stored in cloud increased over the last decade, while the data stored on personal machines as well as on-prem on enterprises started decreasing or declining. All of that created massive demand in IT industry. The processes, tools, and culture we had back in early evolution time couldn't address and support new expectations. And some of our major inefficiencies were manual tasks for provisioning, setting up, configuration, building, deployment, testing, and more. Also, inappropriate utilization of infrastructure. Also, lack of visibility and feedback, and isolated silos by roles. all of these were classic problems of that time. So every company in the industry started hunting for answers. How can they deliver more with lesser time and cost in a competitive market? Also, how can they reduce their infrastructure cost, and how can they make their systems more efficient and quality-centered? During this time, the principles of Agile and Lean started catching attention, as the values they bring on table were believed to be fixing the problems at hand. As you can see here, the 5 major principles of Lean and Agile methodologies. The first one is value creation by eliminating the waste in any form. So any unused feature, unused infrastructure, manual or repeat efforts is considered as the waste and needs to be eliminated. Next thing is delivery. Make your delivery as fast as possible via smooth delivery pipelines. Also, provide feedback as early as possible and as quickly as possible. If you fail, fail fast. And integrity. So integrate quality and performance toll gates into delivery pipeline for the seamless delivery of your code changes to the market. And last but not least, empower individuals for continuous learning and elevating their full potentials. So this Lean and Agile principles were quite tempting. Clearly, organizations started marching towards being Lean and Agile, but the million-dollar question was how. Toyota was the creator and early adopter of these principles, but all they did was in their own manufacturing industry. Our industry was intellectual industry. We didn't really build big machines. We rather produced intellect properties in terms of code and etc. So how can we adopt it all in IT? IT needed a type of culture, set of processes, and tools to unleash the potentials of lean and agile principles. And that's where DevOps came into the picture. As you can see here, with lean and agile principles, as well as the DevOps values, the wall of conflict started getting down. Organizations started breaking their silos and bringing people from development, QA, and operations together to create seamless, flawless, and automated software delivery pipelines. And that was the inception of DevOps culture. As you can see here, this wall of conflicts getting down by Agile and DevOps practices. So DevOps in a nutshell on a very high level is the continuous business planning, continuous development, continuous testing, continuous release and deployment, continuous monitoring, and collaborative customer feedback and optimization, and run all of this as part of your continuous software delivery pipeline. To add a little more detail, DevOps is collaboration between development and operations that basically helps knocking down a lot of siloed problems traditionally we had in our early evolution. Also, it basically is about eliminating manual actions and automating everything we can so that the cost of a change comes down. Also, it is the philosophy of breaking down large releases into small releases so that they become easy to manage and can impact positively on our quality as well as time to market. Other DevOps philosophy is the treat infrastructure as a code to enable dynamic and elastic environments for easy, repeatable, and automated build, rebuild, and tear down of infrastructure as needed. And enable feature switches and toggles to empower teams and applications to release their code changes independently. So that basically empowers the teams and individuals to fearlessly, build, test, and release their changes without any dependencies. And the last is use Kanban to track the operations efforts. Right, operations is critical part of the software development and delivery lifecycle, and that needs to be treated no differently. Naturally, this becomes trendsetter for getting rid of old problems. And no wonder why the demand of DevOps is skyrocketing. One of the major employment surveys shows that as of 2018, 7% of overall IT jobs were related to DevOps. Impressive, isn't it? I couldn't find similar state or data for current years, but I believe it wouldn't be unfair to assume that it is continuously growing even today. Also, DevOps market size in North American region is continuously growing as well, which means there is a continuous increase in companies offering products and services under DevOps space. You can see here in last few years, the market share for DevOps has been continuously growing and has been projected to grow further as we move into future. That also is pretty interesting. Well, I hope this helped in exploring our why for DevOps. Now, since that is behind, let's jump down to how can we enable DevOps for an organization and for our industry. There are quite few definitions for DevOps in industry, as the concept itself is quite open-ended. But I believe that the DevOps is a culture. It is the combination of people, processes, and tools. That's typical DevOps delivery spiral, which shows end-to-end delivery pipeline. I don't really need to explain this. Most of the people basically aware of this and tired of seeing this. But what I really would like to mention here is there are a lot of options, open source as well as commercial, for each stage in this pipeline. And some of them are basically mentioned here. So organizations started pursuing this flawless and high-speed delivery pipeline, but it wasn't that easy. Even though there were tools available for every single phase of this pipeline, and organizations had money to actually buy those, they still couldn't really move the mountain, because it did require a cultural change, right? To bring that change further, industry started exploring the underlying ingredients, right? And there have been 5 very essential DevOps essential ingredients. We'll start with the first one, the leadership, right? The very first thing to actually enable DevOps and bring the DevOps culture in an organization is to get the leadership convinced, right? So the effort needs to be actually started from top and then to down, right? Also, there has to be enough patience, and there shouldn't be overnight expectations. Another thing is eliminate manual actions and automate everything possible, just to make things faster and ship faster. Also, have the APIs and code, codify everything possible. That includes your infrastructure processes, provisioning processes, building, testing, deployment, and any other tools that's used in actually software delivery and development lifecycle. All of that codification is needed to have the seamless integration into software delivery pipeline. So if you use the tools, having APIs and code and CLIs, it becomes so easy to integrate them in your continuous delivery and overall DevOps workflows. Next thing is empower developers to acquire new skills to develop and support automation and other DevOps practices. And the last but not least is a journey. Never treat DevOps as perfection. It's never going to be perfect. It's a continuous journey, and there would always be a room to improve. After getting these ingredients, organizations started making their journey, and they started establishing that DevOps culture. And that basically brought significant values in terms of time to market, increased quality while reducing cost and risk. And some of the major DevOps practices that were used are continuous integration, continuous deployment and delivery, continuous collaboration, and continuous monitoring. Well, during that time, there's also the birth of cloud native, which is a standard or a term used for breaking down monolith into microservices and run them as a containers in elastic infrastructure. The cloud native became so popular because of its own benefits on top of DevOps. So let's quickly run through the aspects of cloud native, which are microservices, CI/CD, containers, and some DevOps practices. Not going to get into details of this, but microservices is nothing but breaking down the monolith. It's an architecture that proposes breaking down of the monolith to get the benefits of scalability, ease of operations, and reduced risk. You can see here on the top right side the green screen that shows about 20 microservices my team built in last couple of years. The next aspect of cloud native is CI/CD, which is also one of the most basic practice of DevOps as well. Organizations also started migrating to continuous delivery from the traditional cyclic delivery of earlier times. This new delivery model helped in breaking down the silos, building cross-functional teams, and establishing the culture of DevOps across organizations. You can see here the new way of building, testing, and releasing software is quite collaborative. The development, QA, operations all work together as one team, and they pull together the delivering of small sets more often and with high quality, just as one single team. We'll jump on to continuous integration here. This concept doesn't really need much introduction. The code changes that the development or developers make immediately kicks the CI job under CI server. There are many open source as well as commercial options in terms of CI servers, and the CI job basically builds the code, runs the unit tests, and publish the results for instant and immediate feedback. The idea here is shift left. So the issues which earlier were found in QA or production are now found at the moment the code change is committed. Next is the continuous delivery. That includes automated deployment for lower environments, including staging, and potentially running broader range of test cases, including functional, integration, system tests, and some more. However, process to deploy in prod is still manual after last beat of manual testing and approvals. So as you can see here in the picture, the CI is further extended to deploy in test and staging environments, and the results kept on publishing, and only the manual step is the production, right? Any step along the way, if failed, immediately the whole pipeline will stop and prevent the code changes from propagating to the next level or next environment. Next is the concept of continuous deployment, which also became so famous, and many organizations actually made through it. The continuous deployment is the process of doing a full deployment end-to-end, including production, right? So imagine a code change instantly travels through series of toll gates and tests, and finally ending up into production environment, creating the real value for end user. That's amazing, isn't it? However, it just depends on the interest and maturity of each team and organization as to how far they want to go with this. Some go fully automated with continuous deployment in production, while some just stops at continuous integration. But one thing is pretty obvious, that if your business requires changes be available to end users and customers on daily basis, automated continuous deployment is inevitable. And the next aspect of cloud native is containerized deployments. As part of the DevOps and cloud native practices, organizations also started using containers to deploy their applications. Containers are popular for their operational ease, scalability, risk adversity, immutability, and optimal usage of resources. Just like the DevOps, even the deployment itself, the infrastructure itself, has evolved with time and changing industry. If we talk about early technology evolution time quickly, there were traditional deployments. As you can see here, the traditional deployments happened on the physical machine, right? So bunch of applications co-hosted, and it basically imposed risk of co-hosting, as well as there were a lot of other challenges in keeping up that model for growth, as well as meeting new requirements. So that traditional deployment basically changed after the evolution of virtualization. So virtualized deployments became the norm after the cloud infrastructure got popular, and many players in the market came with that virtualization products. Multiple VMs run in a single physical hardware, providing the isolation needed for the variety of business and infrastructure reasons. That quite worked well for some time. However, each VM is still holding its own operating system, right? And it basically runs multiple applications on it. So ultimately, your traditional deployment problem is now narrowed down to a VM level, but it's not really gone forever. So after that, with the inception of DevOps, cloud native, and elastic environments, the concept of containerization became quite famous, as it provided needed isolation. Right, the containers can be created with much lighter footprint, and they are normally running one single application. So you get the good isolation from a security and business perspective, and also infrastructure perspective. So this is this is how the container deployment became the standard and the norm for cloud native applications. You can build containers using Docker or Buildah, or there are several other open source as well as commercial options. I'm not going to get into the detail, but on a very high level, to be able to build a pull and push and run the container images, you need the container runtime. And there is a container registry that basically stores the images that you build and publish. However, running containers without orchestration engine like Kubernetes is impractical, as containers require handling storage, scalability, and other operations aspects manually. Kubernetes helps in managing those with great ease and automation. So Kubernetes revolutionized the containerized deployments by providing UI as well as CLI for managing infrastructure as well as application resources. Again, I won't go in detail into Kubernetes here, but on a high level, Kubernetes is a master-slave architecture. Each master basically does the scheduling and provides a variety of other functionality. And the workers basically runs a container runtime, as well as they have the kubelet on them, and they take the order from master and they run the pods, which are nothing but the containers. So as the containerization and orchestration brought in additional values, it also brought in more challenges in our DevOps practices for CI/CD and automation. Now, if you look at the enhanced DevOps workflow, which basically includes the aspect of containers and Kubernetes, it looks pretty complex. It looks quite long, right? But that was all needed to support the innovation that happened along the way in the industry for running applications as a container for a variety of other benefits. So if you can look here, upon the code changes committed, the CI server basically does build the code and run some unit tests, and then it basically builds the container image and pushes to container registry, whether it's a Docker or an Access or Arbor, or whether it's a Helm chart repository for Helm. And from those repositories, the image is further pulled and deployed to Kubernetes development cluster. Then many other different types of tests are ran, and then if everything goes well and smooth, then the changes the images are basically, the containers are deployed to a Kubernetes cluster in staging environment and then production and so on. So this particular pipeline basically shows how much CI/CD had been evolved. Just to add a little more detail to it, with all of this smartness, we also become quite greedier, right? If we can spin up end-to-end environment in minutes using Kubernetes and other cloud infrastructure platforms, why leave the static environments up and running all the time when we don't even use them? So we further evolved our CI/CD pipelines to look something like this. So here what really happens is when the code is checked in, the build and test happens by CI, and then the test environment is provisioned, right? So using Kubernetes CLI, whatever Kubernetes resources are needed to actually run the containerized applications, all of that is basically integrated as part of your DevOps continuous delivery workflow. So creating namespace, secrets, config maps, persistent volumes, pods, deployments, and anything else that you actually need for running your containerized applications is basically now integrated in. After the test environment is set up, the pod is basically running, and the test will basically executed, and result will be published. Once that is done, that particular environment would be destroyed, and if it was all success, then you actually move on to the staging environment and then to production, and you do the same thing, except you don't really want to destroy production environment, of course. Well, awesome, isn't it? All of this looks so great, right? But still, not enough, because the next we're basically entering into the time of hyper risk. So in this time, the security of our systems and data and customers matters the most. Building and delivering faster with quality isn't just enough. We really need to make sure that we build security and safety as part of our normal development lifecycle. As you can see here in this diagram, the usage of containerization has been continuously growing since last several years, and it's projected to be growing further. That's pretty interesting, but it also comes with a risk exposure. The other graph that basically shows that number of security threats and vulnerabilities existing under Linux OS, right? We know that the highly safe and secure systems have been compromised. We hear the news that millions of customers lost their personal data due to security breaches, right? And these graph basically shows that over the last few years, this has been happening more often. This graph basically shows the vulnerabilities existing within the base images of Docker. So as you can see, the Node.js image has 580 security vulnerabilities, while Ubuntu has about 30, and there are several other base images pertaining to different software tools or operating systems carry their own vulnerabilities. So what that means is, when you build containers using these base images, you inherit these vulnerabilities, and they basically inject into your environment and live there. So that brings security into perspective. We can't let the security managed in its own silo anymore. That is the challenge of that is basically the challenge of our high risk time and the era that we are in. And here emerges DevSecOps, yet another role and a revision to DevOps culture. Security here joins a team and work hand to hand with development and operations to build a system which is safe and secure. If we can quickly summarize the benefits of DevOps and DevSecOps, just to understand the difference, DevOps is actually meant for creating that speed and rapid delivery pipeline. It is for reliability, scalability, and collaboration, while the DevSecOps improves agility of the system and considers security automation as part of your overall DevOps delivery workflow. Also, DevSecOps insists on keeping security as a core so that it can easily be integrated into your DevOps workflows. Also, in a recent survey, DevOps professionals mentioned their major security challenges were lack of automated and integrated security testing tools. Also, inconsistent approach to DevOps security and disruption to production from security testing. And also, they have been tired of false positives as well, right? So all of these are today's challenges that the DevOps professionals are facing. They really want to get the security into the DevOps mix, but there are these challenges that the professionals are highly frustrated about. So the industry is still trying to figure out exactly how to deal with this problem. However, there are theories, and there are organizations started doing some work into this aspect. One of the most famous thing is to basically build security controls across your delivery pipelines. So what that means is the major security testing and controls such as static code analysis composition analysis and dynamic code analysis should be integrated as part of your CI/CD pipeline. So normal DevOps workflow is like plan, code, build, test, release, deploy, operate. Right now, if we can inject static code analysis during build and deploy time, it basically gives us many different potential threats, vulnerabilities, and exposures right out of our IDEs or basic CI jobs. Right, there are many tools, open source and commercial, in this area as well. SonarQube is one to name. Also, adding other security controls like dynamic code analysis, composition analysis as part of release and deploy would help tremendously, with the issues pertaining to your, licensing of the open source software, vulnerabilities existing in those, and how much is the exposure. All of that can be basically understood and revealed by integrating the tools which would provide dynamic code analysis and composition analysis as part of their capabilities. And also, as part of this, if your normal issue tracker is integrated within the mix, you have the continuous flow. Right, the code is checked in, the static code analysis is done, and also the dynamic code analysis and composition analysis is done. And whatever issues are found based on the rules that you have set, the issues will be created in your issue tracker. So that basically brings your security early on, versus worrying about that, when the customers, report their data breach or data lost or identity theft. Well, with this, the extra pressure basically came on CI/CD pipeline, as it had to create the space and capabilities to enforce security controls. So as you can see here, the code changes would basically be built not just the normal unit test cases, but the mature team started actually writing the unit test cases for security. So as an example, if you want to make sure that a user of the application does not have an access to do anything other than what he or she is privileged for, it shouldn't be that difficult writing a test case for it. Right, so running that type of security test cases is now the part of CI/CD pipeline, which is security aware. Also, composition analysis and static code analysis are part of the same CI/CD pipeline. And once the container image is created and pushed to the registry, and then the container is deployed in your infrastructure, the functional tests and along with that, more security tests, are ran. And finally, when all of that passed and the container is ready to be deployed in higher environments, the final container validation can be done, as well, which would basically include the rootless container validation and vulnerability scanning, as well as security pen testing and ethical hacking. To add a little more detail to this, we can integrate threat modeling tools and software into the mix to manage security controls and define the rules. Also, we can add static and dynamic code scanning into the workflow by integrating appropriate security scanning tools and software. And also, we can do the same thing for basically adding, scripted, pen testing into the pipeline. So this particular slide shows how much deep and wide DevOps has basically grown today. Right, there are hundreds of open source as well as commercial tools in market to support each aspect of DevOps and DevSecOps workflows. This picture shows a cloud native landscape as of today, and it shows only the most popular tools in the market under DevOps paradigm. There are so many. I have included the link to cloud native landscape at the end of this presentation, so you can go and check those out yourself. But this shows our industry's scale of interest in the DevOps market, and that interest is continuously growing. I would also like to quickly summarize the 5 stages of DevOps evolution. As you can see here, normalized tech stack, which is the very first step of the DevOps evolution, and that is being agile, right? Having all your code, whether it's a application code or infrastructure code or a security code, having that all under SCM is the first thing, and having the automated build tools and capability of CI/CD. That's basically normalizing your tech stack. The second thing is basically standardize the environments and reduce variability, which means if you can keep single OS family across the organization, it becomes so easy to maintain and support, and also automation with the DevOps efforts. Next is expand DevOps practices. Build and enhance DevOps workflows and pipelines to match output of dev teams to expected delivery goals like time, risk, quality, cost. So continuously expand and enhance your DevOps practices until you basically reach the point where you get the desired results. Automate infrastructure delivery. So eliminate discrepancy between dev and operations delivery time. Automate security, network provisioning, configurations, everything, so that there is no one stage through the pipeline becomes a bottleneck and slows down the overall delivery. Also, provide a self-service, which means empower dev teams to elevate great potential by provisioning needed elastic infrastructure via DevOps workflows and pipelines. That specifically eliminates any bureaucratic and manual steps from the process, and creating great potential and efficiency in the process. Well, although it has been nailed down quite clear as to how to enable DevOps for the organization, there is still a struggle in establishing true DevOps culture. There are several reasons to it. There are several barriers that you can think of why the DevOps culture is very hard to build within an organization. So the very first thing is the old and legacy culture, where you have so much of blame games, lack of cooperation, ability to take a risk. Another thing is plan, lack of preset business values and objectives. So pretty much the organization isn't really very sure of the values and how to attain them using automation and DevOps. The third thing is lack of support and budget to create the culture of DevOps, which I have seen quite a common reason across the organization. Other thing is skill set, lack of skill sets to understand the value of DevOps. And then there is a tool chain, which is basically the lack of standardization across teams hindering DevOps transformation. So the organization has so many teams and so many departments. If every team and department does a different thing in a different way and uses different technology, it becomes kind of very hard to make DevOps as a standard or bring DevOps culture. The last thing, which also I see very common across organizations, is legacy footprint. So tech debts in legacy apps and processes, are holding up most of the human and non-human resources. That becomes also a bottleneck for not having enough time and resources to look upon the DevOps transformation. These are the common factors why organizations fail in enabling DevOps culture. I'm sure we'll get better with time. And fortunately, DevOps isn't a closed box. It's a form of culture, and so it is quite open-ended. And finally, I would like to end this session with a positive note. Again, you can see a Buddha here under the open sky, very calm and deeply meditating. Another famous saying from Buddha is, "I'm better than yesterday." If we keep this up in our DevOps space also, that'll be great. There is no end to an improvement. DevOps is a journey, and it has to be continuously improved. It needs to get better day after day. And at last, this is the resource page where you can actually see some useful links. It has a cloud native landscape, as well as Simon Sinek's golden circle theory, and some other video. I forgot about it. And also it has my information. Feel free to connect with me. At this point, I would like to open up for any questions, and if you have anything, I would love to answer. Okay, I see one question here.
Thank you.
Thanks, Mike. I see one question here. Are you using open source Jenkins or Core? How you are handling CD portion of it? Is it possible to demo it? Okay, that's a pretty good question. I have used Jenkins in the past, but currently at my company we use Atlassian product suites. So Bamboo is what we use as our CI/CD tool. We do have continuous integration and continuous delivery. We do deploy code change as soon as it happens into all the development environments. But our higher environments like QA and production are still behind manual testing and approval process. So we have the concept that basically goes end-to-end all the way to the Kubernetes deployment once the code change occurred, but it doesn't really go all the way to production. Hope I answered. Right, Mike, I don't really see any other question here.
Anybody else have any other questions for Himanshu? Speak up now. There's another one coming in here.
Okay.
Let's see when it comes up. Should be popping up shortly. I'll go ahead and anticipate the question real quick before it pops up. Good information as a career point of Kubernetes is good for DevOps containers?
From the career point, whether Kubernetes is good? Is that the question?
Yeah.
Oh, okay. I see it now. Yeah, I believe so. Without Kubernetes, it is very hard to manage containers, as a lot of things pertaining to networking, security, scaling, and other operations, you'll have to do all of it manually, right? If you use orchestration, and Kubernetes basically rules there, right? And there are so many Kubernetes extensions available in commercial market as well. Open source Kubernetes has been extended by many companies and provided their own wrappers and their own extensions, right? So Kubernetes is a kind of a standard to manage containers, and it would be very hard to imagine the life of container without some orchestration engine.
Good answer. Good answer. Let's see if we have anybody else posting any questions. I don't see anything else. Hopefully, well, somebody gets brave enough here to post any other questions. I just want to remind everybody that, again, like I mentioned earlier, if you got on the call late, that on April 17th is the spring break edition of All Day DevOps. And also, despite the COVID-19 scares that we've been having and everything going around the world, we're still going to have the DevOps Days DFW on August 26th and 27th for the time being. It was, I guess, it wasn't clear for Prashant the Kubernetes point in the DevOps containers.
Not cleared.
Yeah, well, Prashant, you want to kind of explain to us what is it that you're looking for? Okay, here we go.
Oh, okay. So, Prashant, it's a great question. Kubernetes and Docker are not really either or type thing. Docker basically is a container. So it's a framework to create the containers, while the Kubernetes is basically the orchestration engine, right? So once you create the container image using Docker, right, you basically need something like Kubernetes to deploy it and manage it, right? So they are kind of like working together. They're not really like either or type things.
It's another question here from Philip Becker.
Well, I think, and that's a great question. If I had to do CI/CD again, what would I do differently, right? And I would say the injecting security is all I can think of right now, because that is what we are missing, right? We do have the security processes which are quite manual, and they come into picture too late in time, and that's not right? So if I have ability to do CI/CD again, I would basically factor security into it, right?
Yeah, hopefully, I'm trying to get a presenter to do a little bit about in the upcoming sessions about Kubernetes security that has to do a little bit more of a deep dive into security in Kubernetes. We got another question here from Nitin.
What is the difference between Docker Compose and Kubernetes? At what stage should one use Kubernetes versus Docker Compose? So I believe Docker Compose is a way to build the Docker image, while the Kubernetes is an orchestration engine which comes after the fact of having Docker image already built or any container image already built and published in the registry, right? So Kubernetes provides the overall container orchestration framework. So you can basically create the pretty much container deployment infrastructure, by using Kubernetes CLI, right, or UI, right, you can literally create a Kubernetes cluster. Within that, you can have Kubernetes nodes, and on those nodes, you can basically have persistent volumes, and you can create namespaces, which are nothing but the environments, and then within those you can basically deploy the container image, which is built using Docker file or Docker Compose. Hope that answered.
That sounds right. See if we get anybody else have any other questions before we drop off. Well, again, I want to thank everybody. If there's no other questions, I would like to thank everybody for joining us tonight on this virtual meetup. For those of you that there's been some questions about the slide deck, I'm going to go ahead and post it here. So you can get the slide deck right there. It's also posted, the URL is also posted in the actual meetup where you RSVP. So you should be able to click from there and be able to download it in case you want to have the slide deck and just review it along with the video after this session. And again, thank you, Himanshu, for joining us, and we hope to have you back on another topic sometime soon.
Sure. Thank you so much, Mike, and thanks everyone for attending and joining with us tonight. Please stay safe and enjoy some time with your families. Thank you.
We got one more question there.
Oh. That's a pretty big one. Yeah. So I think I would say I have just seen the worst. Kubernetes is the best. Certainly, Kubernetes itself is on the path of active evolution, right? It's been continuously changing and continuously evolving. So certainly there are opportunities, but I can't really think of anything top of my head. I wish there was a easy installation out of the box. Many companies who have basically commercialized Kubernetes have started providing easy installation process, but Kubernetes out of the box is very hard to set up. So that one thing I can think of as an improvement, because the fact is there is a big section of people and companies rely on open source, and for them setting it up is kind of a challenge.
Feedback there. And then this question says here for me from Philip, what is the terms of use of the slide deck? I would want to defer that answer back to Himanshu because he provided the slide deck. Sure. There's nothing really proprietary in the slide deck. That's why we're making it available to everybody.
Yeah.
But I don't know from Philip what is if you could explain, what are your intentions? I mean, are you wanting to use it with, to show it or present it to your company or internally to your team, or kind of give me a little bit of feedback, or what is it that you're wanting to do with the slide deck, Philip, to understand it? Oh, not a problem, Philip. Okay, not a problem. commercial use. What would I'm not sure I'm understanding you with commercial use, Philip. Are you meaning probably presented to a customer of yours, or is that what you're kind of asking? In any case, I'm usually on several Slack channels. So if you want to discuss this further, I'm on the DevOps Days DFW Slack channel. I'm on the All Day DevOps Slack channel. I'm on every single Slack channel you can think of. So if you want to ask me the questions, you can ask me that, and we could go in deeper. So yeah, so what Philip is asking Manchu is if he uses this presentation, he probably wants to use it to with his customers. I mean, there's not, like I said, there's nothing proprietary on there. I would just say if you're going to use it with a presentation commercially with your customers, it's more than fair than you probably give credit to Himanshu for creating the slide deck. Maybe put his Twitter feed at the bottom and his name, so people know that where the information is coming from.
Yeah, I don't really mind. You can use however you want to. That's fine. I don't really have anything that's not publicly true, or any secret sauce.
Yeah, and to answer Pure Soul's question is that yes, the recording is up on our DevOps Day DevOps Live YouTube channel, so you can always review it at any time. So it'll be posted there, and if you subscribe, you will get notified every time we have a new YouTube video available. So. Okay, without further ado, if there's no other questions, then there's no other question. Just getting a lot of feedback here. Welcome, Philip. We hope to have more these type. Well, in the next upcoming months, we're hopefully, April and maybe May, we're going to have them virtually, depending on the situation with COVID-19. And like I said, we'll keep updating you as things progress. And on also for related to DevOps Days DFW, we'll have our website constantly updated if anything changes. But for the time being, the event on August 26th and 27th is going to happen at the Plano Event Center. We're hoping to have. Last year we had about 635 people show up, practitioners. We're hoping to increase that to 800 this year, to get a lot of speaking and a lot of open space experience out there. So thank you everyone for joining, and with that, we're gonna call it a night, and we'll see you on next month's DevOps Live meetup. Okay, we'll talk to you later. Take care.
Thanks, Mike. Thank you, everyone.
Thank you, Richard. Take care.